Welcome to WeCount's webinar on AI-powered mobile assistive technology apps, risks, and benefits, a conversation with Dr. Roger Melko. Before we begin, OCAD University acknowledges the ancestral and traditional territories of the Mississaugas of the Credit, the Haudenosaunee, the Anishinaabe, and the Huron-Wendat, who are the original owners and custodians of the land in which we stand and create. For this webinar, we will first go through group presentations, where 5 groups will present their overall findings from previous sessions, Part 1 and Part 2.
Next, Dr. Roger Melko will present and further explore this topic, followed by an audience Q&A. After, closing remarks will follow. We kindly ask that you input comments in the chat box and questions in the Q&A feature before speaking. Please say your name so that we can identify you more easily. And we ask that microphones are kept on mute unless you're speaking. This webinar will be recorded. Our captioning booking for today was superseded by other major events that are happening today. So we have a volunteer captioner. You can turn captions or subtitles on in the menu at the right of your Zoom window. And many thanks to Rachel for bravely taking on this task of typing at supersonic speed. So before our presentations, here's a brief video to tell you a bit more about WeCount.
WeCount, a project of the Inclusive Design Research Center at OCAD University, was created to address barriers to participation and employment for persons with disabilities within data science and data-driven systems. As data becomes the main source for truth and value, persons with disabilities are becoming increasingly marginalized because their needs are not considered within the data ecosystem. Many systems are designed for the cluster of people at the center. For those people, the design works well. As we move away from the center, the design becomes more difficult for people to use and may even be unusable. WeCount addresses barriers throughout the data ecosystem. A data ecosystem is the complete cycle of pieces of information, as well as individuals and organizations within that system. This cycle includes individuals who generate data or information, systems that collect and analyze the data, individuals who build or use the systems, collecting, analyzing, visualizing, and generating insights from data and the decisions made from this process, and training, hiring, and working within data science fields. The goal of WeCount is to create an inclusive and balanced data ecosystem for persons with disabilities and others who are excluded. A data ecosystem that increases participation, addresses exclusion and bias, ensures community input, increases employment, and decreases vulnerability to data abuse and misuse. To achieve a fair data ecosystem, WeCount is focused on sharing current views in inclusive data science, gathering resources, data sets, and inclusive data tools, and involving the community through design challenges, workshops, and events. As the data ecosystem continues to evolve, WeCount is working closely with the disability community and our established network of partners to identify and solve key accessibility challenges. To learn more about WeCount, visit our website or follow us on social media. WeCount is funded by a grant from the William and Flora Hewlett Foundation and is supported by Innovation, Science and Economic Development, Canada's Accessible Technology Program.
Thanks. Now, without further ado, let's move on to the group presentations. Supersense will be going first, followed by MapinHood, Ava, Seeing AI, and lastly, Envision.
Okay, let's begin.
Good morning, everyone. Thank you for attending our presentation on the artificial intelligence app Supersense. This is an app that is geared to assist those with low vision and that are completely blind with reading materials such as documents, barcodes, and currency, as well as deciphering objects within our environment when we are navigating. We would like to discuss the risks and benefits as a group around this app through our experiences. One of the challenges or risks is there's a privacy issue with personal data sharing. So what is our data being used for and when? Such as utility bills, credit card information, etc. There's a lack of privacy data sharing policy, which is also an issue. One of the benefits is the trade-off. So we are sharing our personal data in order to improve and enhance the app itself. Another risk or danger is the fact that Supersense can misread or mislabel objects or information, such as misreading a radiator for stairs, and not sometimes being unable to read coins, change, Canadian currency, as well as foreign currency, which can be an issue. As a completely blind member working in society, I don't feel that this app is safe to use at this time, and can definitely use more testing and improvement, which should have happened before it was released into the hands of those with blindness and that are vision impaired. But I am optimistic for the future that artificial intelligence will develop more apps that will enhance our quality of life. And now I will hand it over to Lynn.
Hi, everyone. Can you all hear me?
Yes, Lynn, go ahead.
Okay, thank you, Tammy. Your feedback is important and should be taken into consideration by Supersense app designers and developers. My name is Lynn. I am a UI UX designer. I'd like to start by saying that our criticism is meant to be constructive, and we do understand how far technology have become in order to make it possible to create a Seeing AI app. So in my opinion, I'd like to second what Tammy said. Supersense appears to still be in the testing phase and perhaps should not be available to the public yet due to many safety concerns. I'm not aware of the exact measures taken before launching Supersense, but moving from a prototype towards a functional product is difficult. And in this case, should have required large-scale user studies. Overall, the app does not seem to understand exactly what a human user with visual impairments might really need. And now to speak briefly about the effects on the community, I wanted to relate to the pandemic that's going on today. So today it is perhaps less acceptable for a visually impaired person to make physical contact with a stranger and request help, for example, in navigating a public space. So I believe that this is the time for Seeing AI to offer the visually impaired and blind community a new sense of mobility independence. And on the other hand, and some additions to the Seeing AI apps like Supersense can improve the overall user experience and maybe help make it more enjoyable for the user. Like, for example, the use of multi-dimensional ear cons or audio icons to indicate exactly where a certain object may be. Another thing that could be added is maybe offering more elaborative descriptions of objects. For example, instead of saying there's a cat, the app can say cat sitting on a couch, or for example, a table, instead of saying a table, it could say a table with a lot of items on it. And I will pass it over to Sean.
Good morning. Hi. Thank you, group members. I'm from Acton, Ontario. I'm a creativity specialist in performing arts and small business improvement startups and closures. The story of how we came to be, we theorized and documented the wave patterns in our brain to give ourselves deeper understanding of the environment that's in front of us and how to go about transforming that environment, not only to suit our comforts within it, but to further seek out new challenges for necessity and comfort. History taught us that through the direction of others, we can learn to better conduct ourselves effectively to better those directions, plus how to maintain our experience within the augmented environment. And that included the differences in wave patterns of persons with physical disabilities. Today, we've learned instead to adapt to our environments around us based upon our very individual complex needs. We cannot afford to lose grasp of inclusion before it really understands the value in what is now the awareness that supports our inclusion. AI in the classroom is not the end of humanity. It is the evolution of our species moving in its natural direction. We like the idea of an eye-in-the-sky society, but we strongly caution the disabled community that we do not exhibit the same state of brainwave, that we are a community among ourselves. The correct professional in any one certain area of medicine or disability are the required persons for hands-on involvement with the creation of official, credentialed, approved rehabilitation tools. The digital world, like Google Play Store, was created by a modern mainstream idea in a complex modern civilization as overpopulation and economical corruption, the effect of our environmental footprint begin to interact with these quantum data input devices. Doing our part is to maintain a standard of awareness, meaning inclusion is where we have the option of using an augmented environment, so that inclusion does not mean I must adapt to using an AI quantum functions parameters of what happiness means to me. Thank you, everyone.
Thank you. So we're a little shy on time, but I'm wondering if, Roger, if you had any comment you'd like to make at this point. I myself noticed an important emphasis on options. How about you?
Yeah, one thing I think which was interesting, an interesting point raised by Tammy was the fact that you know, you're sharing data with Supersense, you know, in order to improve and enhance the app itself as you use it. And a couple questions which you don't have to answer, but which is I think interesting to consider is number one, presumably in the terms and conditions of using the app, a user agrees to do that. And I wonder how we as a community decide how to balance the fact that, you know, we might be protective of our data that's being used to enhance the app, but also we want the opportunity to shape the technology, right? When you feed it your data, whoever you are as a user, you're shaping that technology. And it's not a question, it's more of a comment, but it's something I'll return to perhaps in my presentation. Thanks very much.
Thanks, Supersense. And now I believe MapinHood is going to take the floor.
So hello again once everyone. My name is Chris and I'll be representing our group today. So our journey through this workshop has been rewarding and informative, and our group has definitely been better educated in the use of AI in our everyday lives through this process. So I'd first of all like to acknowledge our team and thank them for their hard work and dedication to this project. Joseph, Manette, Sibel, Lisa, Monica, Karen, or as we like to be called, the group in the hood. We would also like to thank Dr. Melko for his work with AI and his keen desire to make assistive technology better, enhancing the lives of those within the disability community. So our group strongly believes that if all the work, time, money, and effort invested in this technology is able to benefit just one member of our community, then of course it's all worthwhile. So thank you again for your efforts. Our group was chosen to evaluate the AI-powered assistive technology mobile app called MapinHood. MapinHood is a personalized pedestrian navigation app for the GTA and surrounding areas. It's very similar to other apps like Google Maps, Access Now, and Waze, to give you an idea. The app is intended with the use of AI to aid persons with disability in safe navigation of streets, pathways, parks, and accessible features. The app uses crowdsourcing to collect data. Now, our group focused on 5 specific areas of the app: its function, its benefits, its potential, its impact, and of course the safety, fairness, and ethics surrounding the app. Our first discussion point centered around the app's function and whether, after several days of trial, did it actually work for us.
We now
So
have
as a group,
we need to change slides, right? We need to
yep.
change slides.
Flip the slide.
Karen, we think that if you go into presentation mode first and then share your screen, you'll be able to select the correct window. We think that Zoom is on the wrong window. And that will help things along, I think.
I will do that while you continue, Chris. Thank you.
Yeah, okay. I'll continue on for the sake of time, absolutely. But the visuals definitely do add. You know, so as a group, we found that MapinHood, it did not fit the lifestyle of a person with a disability. We found that it was slow to react, it wasn't very intuitive, and some of us actually found it difficult to physically access and use. The app itself was unable to correct or make changes. It was at some times very disorienting and confusing. It uses only a graphic visual presentation, and it definitely needs a full textual option. For someone with navigation challenges, the app amplified those challenges rather than reduce them. While it did speak directions, which would be useful to a visually or spatially impairment, they were spoken after the turn was made. So for example, it might say, turn right onto your Ontario Street 3 meters ahead, but was actually spoken 3 meters too late. So our conversation then proceeded with the app to discuss the possible benefits of the app. The app was designed to enable people to identify hazards, amenities, points of interest, and path features. In theory, this could potentially help people meaningfully navigate their environment in real time. You know, for example, finding things like benches, garbage cans, drinking fountains, washrooms, healthcare facilities, crosswalks, stairs, seasonal hazard, construction, and even an escape feature or a quickest way home. Finding these landmarks and alternative routes is extremely useful for persons with both visual and invisible disabilities. Disabilities can be intersectional. The experience of barriers for people with multiple disabilities can be compounded or cumulative and amplified. So as a result, our needs are layered. For example, identifying temporary construction sites and routes around them can be especially helpful for those people who have respiratory conditions and difficulty navigating changes to their regular routes. So what is the potential versus, say, the privacy and the bias? So the app was designed to collect our personal information. For example, our travel routes, places of interest, time of our daily travels, and tags. We as a group were concerned about how our data is actually being collected and how it will be used now and in the future, and who actually has access to our information. There isn't really any transparency within the app as to why the information is being collected or how it's being used and how it could be used in the future. The more I tag, the more data they collect. This poses several questions for us and concerns. Who can access what people tag, both now and in the future? Could our personal information be shared with police or other authorities? Are some populations more at risk than others if they use the app? If this app is more accessible or usable for some populations more than others, how will this distort the type of tags that are being placed, and who will be left out from further use? And does this problem of dominant voices amplify over time? What are we trading off? What are we compromising to get our needs met? What then is the impact of AI on the quality of life for individuals within the disability community? If the app worked as intended, it could improve the autonomy of people with disabilities and meet us where we are. It could reduce the friction of barriers by helping people navigate around them, and therefore improve predictability, which could in turn reduce stress and anxiety and improve the safety and quality of our lives. However, this can be a double-edged sword. When we cede control to an app that uses artificial intelligence, including machine learning, to meet our needs, we are vulnerable to the implications of hidden decision-making. The decisions, while well-intended, are founded in historic and systemic bias. For example, how infrastructure, services, and authorities have responded to certain neighborhoods. Without participatory engagement in the decision-making process, are we letting the app decide for us how we connect within our own communities? AI is a black box and uses algorithms to analyze data and make predictions in unknown ways. Who's behind the curtain and pulling the strings? Who actually is the wizard in The Wizard of Oz? So what then are the safety, fairness, and ethics of the app? Our group concluded that this app can be unintentionally unsafe, unfair, and unethical if the risks aren't recognized and mitigated. It is not only about the construction or coding of the app, but what it uses or favors and for what purpose, and how it is used to amplify social bias and discrimination. For example, unsafe if someone else accesses the information and uses that information against a person or group. Unfair if some neighborhoods may have a more robust database on bias more than others. How about unethical? Who are the third-party users, and where is our information being used both now and in the future? Who is accountable, and what mechanisms are built in to govern the ethical, fair, and safe use of collected data that informs AI? Our group discussion raised a lot of thought-provoking questions and concerns surrounding the use of AI and its use in assistive technology mobile apps. So in conclusion, I'd like to now turn it over to another one of our group colleagues for our closing remarks.
Good morning, everyone. In conclusion, the app does not seem to work as it should. Therefore, it is not beneficial as intended. We find it disappointing and frustrating at the same time. Usage data is automatically collected when using the app. We find collecting personal data such as Internet Protocol address, the type of mobile device used, the mobile device unique ID, the IP address of the mobile device, the device unique identifier, how one interacts with the app, and other diagnostic data, whatever that means, alarming. It feels like stalking. Even more personal data can be collected when one signs up through a third-party social media account. We don't see what or why collecting personal data, such as someone's activities and contact information, has to do with an app that is supposed to make people feel more independent. We do believe that AI and collecting personal data is unsafe, unfair, and unethical. We believe that the individual should have control over how much information he or she is willing to share. Who knows whether all data that is being collected is for improving the app or other uses? It is a scary feeling knowing that every time we interact with the app, personal data is collected, stored and used for multiple reasons, and that we have no control over the data that is being collected. Persons with disabilities are a vulnerable group of people striving for equality and independence. Because we try to be independent, we may try new AI innovations that promise independence. By only thinking about the pros and completely neglecting to think about the cons. There should always be an option to share or not to share personal data through AI. And this option should not exclude anyone who chooses not to share that data from using the AI or application. Thank you very much.
Thank you, Group MapinHood or Group in the Hood. That was excellent. Enjoyed that. Roger, did you have any comments you wanted to make before we go to the next group?
Just a quick comment. It's great to hear all the participants and presenters so far, being aware of security and bias issues surrounding data. Chris said something important, which is that there's a historic and systemic bias in data sets that have been used to develop AI. And this is one thing that I'll also focus on in my presentation. I'll show some examples of historic data that displays a systemic bias, which has been affecting the technology to this day. So thank you very much for this presentation.
And now I'd like to suggest that the Seeing AI group, unless I've got my order incorrect, someone tell me if I'm wrong. Okay, so I'm going to assume I'm right. So Seeing AI, are you ready to present?
Sure. Give me 1 second to share my screen.
And I'm going to let other groups know that we're perfectly happy with you taking over the screen while we discuss the previous presentation, so you're able to get set up, and I see you're ready to go. Okay, Seppi.
Yeah.
Good morning, everyone. Our group is reviewing the app Seeing AI from Microsoft. It's a well-named app. It's artificial. It's targeted for blind and low vision users to use artificial intelligence to understand their environment. Sepida is our facilitator. Our group members included Anthony, Leslie, Ortiza, Christine, who will be presenting our recommendations for companies that create these apps and government to help govern these things at the end, and myself, David. So on our first slide about Seeing AI, it explains how it uses the camera on your phone to gather information from the environment. And it has 9 different modes. So this app is fairly mature, much more mature than Supersense. And it can do a lot of different things, or attempts to do things, shall I say, because it's not very accurate yet. It needs more data, more work to make it better. So it's got short text, so you can look at like household products to gather information, and it can use OCR to do that. It does document recognition, bigger documents. It seems to do a little better job on that. It has barcoding, scanning, reading for UPC codes, although it doesn't always have all of the Canadian products in there. And it's sometimes hard for a person that's totally blind to actually find where the UPC code is to start with. It has facial recognition, and you can teach it to recognize people and friends. It has ability to do scenes. These are all different channels that you need to select in the app, by the way, and sort of modes. Supersense tries to do it all in sort of one mode, so this is different. It has a currency mode, which does okay in bills, not so great for coins. It has light sensors, so if you're totally blind, you can point your camera and tell where a light source is, or if there's light coming in the window. It has the ability to tell you different colors if you pointed at clothing, although that's pretty dicey. It doesn't do the best job depending on the lighting conditions, so we don't recommend it for fashion coordination. And it attempts to read handwriting. And once again, these things are somewhat immature, and with a lot more usage and data, they may improve, but they seem to have some limited capabilities currently. So moving on to the benefits of this app. One of the main things about this is that Microsoft has made Seeing AI free, a free app. So it's easy for everybody to use. It's widely available. It works on an iPhone, which most blind people use. And it's backed by, all of the power and might that Microsoft has behind it. So there's lots of resources and help that you can get for it. So one of the things that in the scene things that we noted, that if you're totally blind, you can point it at a deciduous tree in the fall, and if it's got different colored leaves, it can actually say, oh, a tree in autumn. So it does have some smarts behind it and can give you some valuable information that if you're totally blind, you wouldn't otherwise get. So in the next slide, there's other benefits. Is it does enhance the quality of life for people that are low visioned. And by helping them be more independent, they can read products in their house, documents, maybe their mail, and various other things to give them more information and be more independent. And if they can do that, then they can be more independent and feel like they're more part of society and contribute. Helps their self-esteem. So moving right along, in the sake of time, to some of the costs/risks of the product and the app. One of the things we noted that there's terminology that's used by the CNIB. Another thing is that the target for this app is an at-risk population. So this service or this app, targets this at-risk population. And so that there's certain things that need to be precautions that should be taken. They use this app because they need to. It's not like it's a recreational Netflix or some other application. Like Chris said previously, we are giving freely up of our data and information in the hopes that, you know, it'll help the database and the AI to improve. But we know, you know, we are giving up our data, even though there's disclaimers at the beginning. After a while, you kind of forget the disclaimer, and you have to really spend a conscious effort on what you're pointing your cell phone at, to be careful on what data you are sending to Microsoft. Because you could be giving, you know, personal pictures of people or personal sensitive documents. So on to the next slide. There was really very little information up front, even though there was a long disclaimer on exactly how this data that you get sent off to Microsoft is going to be used, and how and who could use it. What could it be sold to third parties? Could it be given to the government? And just generally, you know, how this data can be used, how long it can be used, who it can be used for, and by whom. So that we have a lot of concerns about the usage of it, like the other groups. Okay, and now I'll pass it on to Christine to go over our recommendations.
Hi, my name's Christine Malik. Some of the recommendations that we came up with, disclaimers are, you know, we should all read them, but we don't always read them. And sometimes they're so verbose that they're not accessible in sort of the general societal sense. So we talked about the ways that disclaimers could be embedded in the process instead of being one document that you have to read, so that as you go, you're being reminded about how data is being collected and used as you go. So for example, the facial recognition, when I tried to label someone, it said, oh, you should check with them and make sure it's okay, which is a great reminder. And reminders like that would be helpful when you're, say, pointing your camera at your mail or your documents, because those are even more personal to yourself. These apps are looking into your home, and so it's a bit of a trade-off, because we understand that data is necessary in order to develop artificial intelligence, but these the data that they're getting from us as a vulnerable population is a bit unique. I don't think there's too many other populations that are pointing cameras at personal information or the inside of their apartment and sending it into the cloud. So it's a bit of a special case. So slide 8. It would be good to have an easily accessible option to opt out of the data collection, and to inform users about how the data is being used a little more specifically. How is it being shared? Is it being sold? What is the fate of the data that we are giving? We wondered about who else gets access to the data, and so if it is lent or sold or shared, and how long do those stipulations stay in place for? So is there a time limit on those? And slide number 9, we talked about recommendations for government. So the thing is, technology is moving so quickly that we worry that government is perhaps not able to keep up with how rapidly things are changing. And so we hoped that there would be policies in place to enforce protection of the data collected through Seeing AI, and to prohibit the release of the data or the spreading of data, our personal data, to other organizations. We'd like to bind companies to be transparent about how the data is treated, and just to have a general sense that this is a trade-off. And so it is a free app, and it does give us unprecedented independence, but we are also giving something back, which is access to data, which will help to develop AI. So I think an awareness of that is something that we all wanted to keep in mind. Thank you.
Thank you very much, group Seeing AI. Roger, did you have any thoughts you wanted to share?
It's a very interesting contrast to do a case study on Seeing AI versus Supersense, because Supersense is a spin out of, I think it's MIT. It's like a startup, whereas Seeing AI is part of a huge tech giant, Microsoft. And so it's interesting to hear your concerns around data privacy and to think about how data might be used by a small startup versus, you know, really a tech giant, where these tech giants themselves have a power that really rivals government, right? And so I think it's, I think Seeing AI really brought up this interesting point. Thank you.
All right, and now we're going to hear from group Ava. And I believe Sandra is going to get us started.
Good morning, and thank you for including me in this project. So we had, our application was Ava. And what is Ava? Ava is a voice to text and a text to voice app that transcribes in real time your conversation. If you're not connected to data or you're not connected to the internet, it doesn't work as well. Ava promotes itself as an accessibility app that helps the deaf and hard of hearing community. And Ava has a free version and a pro version that allows access. The pro version allows access to additional tools and better accuracy. And we have a short video.
This is a demonstration of Ava. It gives live subtitles as we speak.
This is a demonstration of Ava. Ava gives live subtitles as we speak. You can see that there's a little bit of changing sometimes to our text as Ava thinks. Well, sometimes she thinks.
We found with Ava that the app infantilizing, I have trouble with this word, I'm very sorry, infantilize the disabled and the disability community. It means that treating us like children or less intelligent because of our disability. Ava automatically censors curse words, and the setting to turn it off are difficult to find. Her default is the default is no cursing, like it censors out, and the default is also a male voice. And even in the free version, even when you change the default to female, you still get a male voice. So we're dealing with, again, systemic design problems here. And we have another video.
Hey, what the? Just a demonstration, folks. I don't usually swear.
It's fixed. Yeah, not so much. Ava puts the onus on the person with a disability to create the accessible situation for themselves. The app asks the person with disability to ask their friends and their colleagues to download the app as well in order for the app to work at its top performance level and in order for them to be included. And considering the social model of disability, where disability is created by society, a service that was available freely in public places would greatly serve individuals. Like, we would like to see, like, when you go into a restaurant, a shopping mall, a hospital center, and you have free Wi-Fi, these kind of applications are made available to you for free. That's the ideal. AVA was designed, and I think a lot of these apps are designed with assumptions. We're concerned that AVA and many other apps are designed for the user using assumptions about them, rather than designing with the user and their first-hand perspective. And here are some of the assumptions we discovered with AVA. People will be able to speak loudly and enunciate with no accent. So someone with a francophone accent speaking English, AVA would have trouble picking that up. Would AVA recognize a deaf accent? Someone with a severe speech impediment, she would not be able to pick that stuff up. And you have to rely on also, and it's assuming that others will be willing to download the app to create a better experience for the person with the disability. The clean language, assuming that, oh, no, we're not mature enough, or we're not adult enough to make our own decisions rather on the wording we use. And that people will prefer to have a male voice speak for them. It might be a platform issue. The iPhone with the professional version enabled the female voice, but it's the same voice that's used for voiceover technology on the iPhone. Only spoken words are important. They don't document any other sound. Like, you could be communicating with someone and it could be raining outside, and it won't recognize the ambient sounds. Needs for exclusions are defined very narrowly, and using these assumptions using these assumptions will only result in exclusion. I think I said that right. Now, how does AVA work? User data and other people's data train AI systems. The user data and other people's data train AI systems to recognize, predict, and transcribe language. AVA sends the user's voice or text data to the cloud and uses machine learning to best support speech to text and text to speech in real time. What happens to our data? That's a concern. Where does it go? AVA does not make it clear about where our data is going and how it's going to be used. The terms of service do not disclose whether the conversations are being stored, how much microphone access AVA has, and what the collected data, if any, goes toward. The terms of service and the agreement is very hard to find after you're in the app, and it's all in legalese. It's not in normal, simple, easy to understand language. And it was very confusing for our group to understand and figure out where the data was going and what permissions were needed, and whether our personal information would be scrubbed from the data and they would just be using the bare data. So for us, with 5 or 6 minds together trying to figure it out, how is one individual going to figure it out? And there doesn't seem to be a way to change the access or control what's being done with it. And we wondered also if PIPEDA does cover the apps. And PIPEDA is the Personal Information Protection and Electronic Documents Act. It's the federal policy law for private sector organizations in Canada. it's not clear. If Ava's an American app, does our laws cover it? You would think that they're marketing it to us and we're possibly paying for it. So it's not clear at all. The app privacy is too confusing for the regular user. We think that where apps are for accessibility, then the app producer should go beyond the minimum for transparency and ease of understanding. So minimum code, minimum expectations no longer play in this. They have to go above and beyond. So our summary. We see the benefits and the potentials of apps like Ava, but there's so much room for improvement. The infantilizing needs to be removed from the system. Placing the onus on the person with disability needs to change. We need policy and social change to build a culture of inclusion so that accessibility tools like this are built into our systems. We need to remove ableism. We need to figure out how to do this and protect privacy. A better balance needs to be represented in the AI-driven products with co-design and representative data. Privacy, security, and ownership of the data needs to be clear and customizable for each person. More control over data uses must be given to each individual. They have to stop taking our rights away and allowing us to make the decisions. That was our findings. That was what we discussed, and we feel that there's a long way to go. There's a lot of work to be done. Thank you.
Thank you very much, Group Ava. Roger?
Very nice, Sandra. Thanks so much. Just one kind of quick thing which struck my mind. Since we're talking about voice to text, and in Ava, you're inputting, literal audio voices. Yes, what the app currently does is translate it into text, but in the meantime, as you demonstrated, it also does a lot of interpretation and so on. And what you might not be aware of is, if provided enough data from voice, we can take those conversations, or our artificial intelligence can take those conversations which are being stored and actually use them to generate new conversations. And I'll show you a text example in my talk, but isn't it frightening in a way to think that, if you speak enough into an app, the app can later, after being trained on your voice, generate new conversations that didn't come from you, but, could fool sort of the average listener. So I think it's something really interesting in terms of privacy that your presentation brought to mind.
I just to add one more thing, I don't think people realize when they say it's a smartphone, it's a smartphone. Okay. My nephew and I were talking about this because I was going over the presentation with him, and he said he has an iPhone. He never told Siri where he worked. Okay. But Siri automatically, she tracks his route and tells him he's leaving home and going to work. And he knows exactly that home is here and work is there. So the AIs in our phones, our smartphones, are actually learning constantly.
Certainly, and one point is, I think it's, as you've demonstrated, the iPhone has the ability to take Ava and use Siri's voice over top of what Ava's giving you. But since you're speaking into your phone all the time, what's stopping Siri from using a replication of your own voice?
But it's not Siri's voice that they use. It's actually the voiceover technology within the iPhone for someone who is blind.
Got it. Okay.
Yeah, the two different voices.
Thanks so much for that.
Great. And now our final group, I believe, is it Envision?
It is.
Okay.
Is.
And I realized before you begin, Doug, I'm just going to in the chat drop the names of the group because we didn't include that in our presentation. So it's Doug who will be presenting today, Richard, Cecilia, Sahang, who couldn't be with us today, Rob, and myself. Take it over to you.
Okay, so we've got the screen.
We can see the screen.
AI-powered mobile assistive technology apps. Envision AI. This app uses your camera and AI to scan, read, and describe items in your environment. Benefits of Envision AI. Easier access to information. Identifying objects, scenes, people, and documents. Increases independence. Boosts confidence. Concerns. Security of the servers where personal data is stored. For example, people's faces and identification. Privacy of sharing images of your surroundings. Lack of privacy and discretion while holding your phone up to use the app. Not identifying things accurately. Which could pose safety issues. For example, misidentifying or not identifying stairs or a curb. The app is quite slow. It is manually activated and can take several seconds to provide information. Government policies and regulations need to catch up with AI technology development. Ideas. Want to be able to have the app on all the time. Provide real-time information on an automated, ongoing basis. For example, scanning your surroundings as you walk down the street. Ability to voice trigger the app and ask it questions. Being able to more discreetly use the app. For example, using the app with glasses. Where possible, information should be processed on the device itself, leveraging the built-in technology. This could be faster and improve privacy. Integration with human-assisted apps such as Ira or Be My Eyes. Now we have a couple of questions for Dr. Melko. In what direction do you see these apps developing to further support people with disabilities? That's question one. Question 2, how can we ensure that the data the app collects and learns from is representative of diverse needs and groups? Thank you. Thank you very much.
Thank you, Group Envision AI. Now, Roger, we're going to be hearing from you shortly. I don't know if you would like to respond to those questions now, or if you're going to integrate them in your talk. Why don't you let me know what works for you?
I can do a little bit of both. So regarding the first question, I believe further development of the apps will sort of go hand in hand with further augmentation of reality, or the development of augmented reality tech. And I'll talk a bit about that. But it's interesting that you mentioned, say, glasses, or I'm wearing earbuds, or we can imagine wearables, and I'll talk about how we interface with technology. But I gather from your presentation that discreteness is important, and that's something that I've taken away from it. You could imagine that you want to have, say, discrete interface with the apps. But say, imagine that you're collecting images through something like glasses. You also have to balance this with the privacy of the shared images, which is something else that you mentioned, Doug. And you have to be aware that people in shared images, for example, can have their faces detected, even now these days, through masks. So it's an interesting point. The second point is it's all about data and the the inclusiveness of our data, and the fact that we need diversity in the data sets that are being used to train these apps. And I'll talk about that, I think, during my presentation. So thanks very much for this one.
Okay, and Celine, I'm going to move it over to you.
Thanks, Vera. So thank you everyone for presenting. It's really interesting to see what all groups have accomplished over the past weeks. I can see you really dove into the risks and benefits of AI. So next we'll be moving on to Dr. Roger Melko's presentation. So let me introduce Dr. Roger Melko. He's a professor in the Department of Physics and Astronomy at the University of Waterloo, associate faculty at the Perimeter Institute for Theoretical Physics, Canada Research Chair in Computational Quantum Many-Body Physics, and faculty affiliate at the Vector Institute for Artificial Intelligence. His areas of research include quantum matter and the development of efficient algorithms for simulating quantum mechanical systems on classical computers, and the relationship of these methods to machine learning in quantum information science. So this workshop was inspired by Dr. Roger Melko's CBC Ideas podcast about AI and machine learning, allowing computers to learn, think, and dream. Near the end of the CBC interview, Dr. Roger Melko says, science and technology progress much faster than policy in many areas, and much faster than our ability to keep up with the ramifications of what's actually being invented. Dr. Roger Melko talks more about how technology may advance and affect societies now and in the future. He raises an important point, and this inspired the focus of this webinar and a question that we asked groups to think about, which was, how would AI impact society and the way that we live, work, and interact with people? How would it increase or decrease inclusion or equality? In this podcast, we're really interested in Dr. Melko's take and enthusiasm to study and question these technologies and how he can further explore this topic. So now, Dr. Melko, you have the floor to present.
Thank you, Celine. Let me share my screen. Hopefully this works. And I hope everyone can see that. And I'm just going to press play here. Celine, maybe you can tell me if this is coming through. Great. So thanks again, Celine, Vera, Gloria, and everyone who facilitated this workshop. It's actually been very educational for myself. So again, thanks for the nice introduction. I'll just skip over the first slide that shows some buildings and get right to kind of, I believe it's the, really in some sense, the topic of conversation now. And I pulled this from the description of this workshop. Artificial intelligence is rapidly advancing to think like us and to deep dream through machine learning. How can we leverage this technology to improve accessibility and at the same time keep up with the ramifications? So this is the words of the workshop organizers, and I think this is a very sort of wise set of questions. And you've all explored these set of apps, and what I'd like to do is dig a bit deeper into some of the concerns raised by the presentations along these two lines. And I want to particularly emphasize this point of deep dreaming later in my presentation, which has some analogies to, I think, what some of you presented today. And then we'll close with a brief discussion of the ramifications. So, as every presenter, I believe, amongst you emphasized, the key, to artificial intelligence is very much the data that artificial intelligence is used to make itself intelligent. So it's we are used to computer programs being blocks of code, and there certainly are architects who design artificial intelligence systems. But as you rightfully emphasized, and in my opinion, it's much more consequential in terms of this sort of behavior of the artificial intelligence systems with regard to what data they are being fed, rather to the actual code architecture. So focusing on data is the key. And I want to address 2 points. First off, how is data used to make computers intelligent? So I want to sort of do a not very technical, but hopefully a slightly technical explanation of machine learning and neural networks and how they use data to learn. And then the second point I want to address is how we humans produce and consume the data that is used for part 1. So I'll get back to that, but so let me focus on how data is used to make computers intelligent. And I think for all of you who interface with these apps for a week or longer, you got a great sense, I hope, of that your data and the data of people that have come before you has really been leveraged to train the apps that you are using. So for example, when you take one of the apps like, I don't know, maybe Supersense, and point it at a dog, what the app can produce is what in artificial intelligence research we call a label. So for example, I'm illustrating sort of a phone, which is held up to a Labradoodle, and this one in particular is Google Lens, but Google Lens is labeling, inside the phone, the dog breed. And the phone, of course, could also, instead of text, could also say, speak that to you through Siri. And I want to use this example of cats versus dogs, and I've used the emojis at the top when I say dogs and cats, because I want to emphasize that this is a label. And an emoji is a really nice sort of way of concisely saying that this is a representation of some object in an image that I can assign a distinct label. So of course that image of the Labradoodle is many pixels. So it comes in from your camera. So all these pixels somehow go into this artificial intelligence system and they produce a label, say cat or dog. So how do we teach artificial intelligence systems to distinguish between 2 different labels? I've illustrated on the screen a very simple type of neural network. And I'll just describe it quickly for those of you that can see it. On the left-hand side, I have square pixels, which I'm imagining can take binary values, or maybe black and white values, or maybe a grayscale value, or they could be colors. And what I'm imagining is that that picture of a Labradoodle or any dog or any cat is kind of decomposed into its constituent pixels. On the right of these pixels is, I've illustrated a deep neural network, which is edges and nodes, or it's lines and little circles, which in some sense represent the signal or a signal which propagates through this deep neural network. And what we do in artificial intelligence is we encode this neural network virtually in a program, but it's not a static object. It changes based on the data that it's exposed to. So when I train a neural network with the data that you upload, to Facebook, to Instagram, to any of these apps, to Microsoft, to Google, to Amazon, really what you're doing is contributing to the training of one of these neural networks. And typically what happens in this training is thousands or millions or billions of pictures are forced into the left-hand side of that neural network, along with labels on the right-hand side. And so the labels are sort of the bottleneck in some sense, in this case, of the neural network. And I imagine a signal that's propagating through from the pixels of the actual camera image to the labels. And if I reinforce pictures of dogs with the label dog and pictures of cats with the label cats over and over, what I do is I strengthen some of the, I strengthen the pathways for the signal propagation in the neural network. And so what I've illustrated here is some of the lines are thicker than others. And so this is the learning procedure. When we talk about machine learning, this is really what machine learning is. It's taking all that data and it's taking curated data where I might have had humans assign labels, cats and dogs, and it's used to strengthen those pathways, okay? And how do those labels get attached? Well, it's by you. Every time you tag somebody on Facebook or Instagram or something like that, you're assisting in this labeling of the pixelized data. So then after this, these network connections are reinforced, some are thin and some are thick, we can show the neural network new instances of data, okay? So here's a picture of a dog that the neural network has never seen before. And if it's trained properly, the signal will propagate through the neural network through this myriad of pathways, and hopefully it'll fire that last neuron, an analogy to a human brain, which is associated with that label. And similarly, if I fed in a picture of a cat, a picture that the neural network has never seen before, if it has been trained correctly on previous images, it'll fire that neuron that's associated with the cat label. And so in this sense, you're discriminating between dogs and cats, using the neural network. And most of the apps that you used, most of the functionality is sort of this discriminative functionality, where you're sending in a camera image or you're speaking, and what you're doing is you're associating either a photo or a word, with a label or its equivalent text. And so these pathways that are strengthened in the neural networks, which are massive machine learning architectures, typically housed on the cloud. Your phone has some local neural networks inside of it, but some of these things are very large, especially the ones at Microsoft and the big tech giants. You're basically participating in this machine learning infrastructure. So what these apps partially do, but not fully, is something we call generative. So I've discriminated between cats and dogs, or trees and houses, or English and French, but I can also generate with neural networks. And this is something that we have to be aware of going into the future. So imagine I have this neural network that I've been illustrating, and instead of using it for discrimination, I quote unquote run it backwards. Maybe I put a signal in the right-hand side neuron that's associated with the dog label, and I ask it to generate what it thinks a dog should look like, okay? And you can do this. There's lots of examples of codes and algorithms that do this. You can do this on the internet. And depending on the sophistication of the neural network architecture, but also how much data you've trained it on, you can get images that look like kind of, you know, hideous images of dogs and so on. My favorite example is a neural network that's trained to discriminate between both dogs and plates of spaghetti. This is the one I used in my CBC lecture. And if I deep dream with this neural network, which sort of means running the thing backwards, it'll output images like the famous dog spaghetti, which if you can't see it, you're really not missing much because it's a hideous mashup of sort of dog faces in a plate of spaghetti. But what's remarkable about deep dreaming is that these are new images, you know, generated by artificial intelligence that are very, you know, very good at fooling sort of a human eye. It seems fun when we're looking at pictures of dog spaghetti, but you know, this technology is also very, very advanced in the realm of what we now call deep fakes. And so deep fakes, and I can show you an example, but I don't know if any of you have seen the movie Step Brothers. There's a new deep fake out on the internet where Will Ferrell and John C. Reilly are replaced with Sylvester Stallone and Arnold Schwarzenegger. Okay, and I just want to try to play it. I don't know if it'll work, but I'll just play it with some audio just for a few seconds here. And let me share screen. And let me share my Safari. And let's see if the audio comes through.
I can't believe you hit Derek. I know, did you see the expression on his face? Yeah. That was cool.
Do you want to see something super cool that only 3 people have ever seen in their lifetimes? Okay, open your eyes.
Whoa.
See that black smudge right there on the blade?
Yeah.
Look at it closely. Pretty recognizable signature.
No.
Randy Jackson from American Idol.
Why do you have Randy Jackson's autograph on a martial arts weapon?
Because I bumped into him and all I had on me was this samurai sword, and you're not...
Anyway, I just wanted to illustrate that because, you know, the technology of deep fakes, which is very similar to deep dreaming, has superimposed Sylvester Stallone and Arnold Schwarzenegger's faces onto that video. And it's done it in a seamless way. And I just got a comment here. It doesn't seem like they deep fake the voices. I think you're right. Although I can't, yeah, because Arnold's voice is very unique. But there's another deep fake with Obama that I believe you could Google and see an actual voice deep fake. But so that's a concerning technology. You know, it's concerning that you know, a deep fake can be used to essentially, you know, fool people regarding the content of something like that movie. I mean, it really goes to show us how fragile our sort of information is. So deep fakes are really a type of generative or, you know, deep dreaming technology. So all that data that we use or that we sort of give to these apps and to these giant corporations can be used for all sorts of purposes like that beyond what you may originally envision your data being used for. And that comes to the second point of my talk is, you know, how do we interface with the, you know, the computers, with the devices, but also with these massive artificial intelligence systems which are being built on the cloud. And this leads to the important kind of topic of bias in data sets, which many of you pointed out. So as you're aware, you know, artificial intelligence systems themselves are coded by, I would say, a certain community or sort of demographic of computer scientists and people like me, you know, STEM practitioners, engineers, scientists, physicists, things like that. And we have to ask, when we develop this technology, what kind of bias leaks into the systems? And in the case of artificial intelligence, you are all right in pointing out that it's really data which propagates a lot of the bias. And it's not just current data, it's historical data. So this is an important study from a friend of mine. I put a link on the bottom, which shows bias in historical data sets. And so there's a chart that I'm showing that shows the percentage of mislabeled images. So you think of mislabeling as if that neural network was shown a picture of a cat, but it labeled it as a dog by accident, that would be a mislabel. And historically, starting in 2012, largely driven by Jeff Hinton and groups at University of Toronto, there was a revolution in the accuracy of deep neural networks. And so this chart lists some of the state-of-the-art neural networks starting in 2012. So what's interesting about the development of these deep learning models, largely done at the University of Toronto, but elsewhere, is that they relied on a set of standard quote unquote data sets. And you can access these on the internet. And ImageNet, IMAGENET, ImageNet is one of these standard data sets which was used to train and develop our current generation of deep learning technology. But what people have discovered is that, you know, these data sets, which include, of course, pixelized images and also labels. So think of it as, you know, the pixelated image of a dog, and then the label, say, Labradoodle. These data sets themselves, which form the basis of the training technology or the training data sets, were mislabeled. And a lot of the labeling was done sort of by farming this out to, you know, there's millions and millions of images, so they were farmed out to a large proportion of the population. And I've shown an example, 3 images, one that says basketball, one that says ping pong ball, and one that says hairspray. And if you look at basketball, you'll see, I think it's a picture of Obama throwing a football. If you look at a ping pong ball, you'll see a Chinese gentleman who's easily recognizable, and it looks like part of the communist flag. And hairspray appears to be some sort of, I guess it's a guy that may have hairspray. So I'm not sure if that one's mislabeled or not. But it's fairly easy to argue that these labels, which occur in the historic data sets, ImageNet is one of the important historic data sets from which all of our artificial intelligence algorithms have been developed, have a bias in them. And there's a lot of research currently going on to address these biases. And I encourage those amongst you who are interested to check out that paper. So these are famously biased data sets. And I also want to point out that data, bias can leak in not just in labeling images, which is, or videos, which is one concern, which was raised, but also in generative, sort of generative neural network or generative machine learning that is based on language, like natural language or text. So I've put a website here for text completion. So what this uses is a neural network called a transformer to complete the text. I encourage you, I can do a demo, but I think I won't. I'll just encourage you all to play with this on your own time. So what I've done here is I've just cut and paste an image from my web browser where I was prompted to enter the start of a sentence, and this technology, which is like a deep dreamer or a generative neural network for text, completes it for me. So I wrote, "Toronto is the best city in the world for," and then I stopped and I clicked the blue button that said generate, and what it did was complete my text. Toronto is the best city in the world for, and this is what the computer generated, your investment in the digital economy. It is a vibrant hub for innovation, bringing together a globally renowned community of experts, entrepreneurs, innovators, and innovators. Okay, it's not perfect. With our support, we will make your digital investments greater than ever before. For more information on the great things happening in Toronto's digital economy, click here. It seems fairly benign, but you have to remember that the transformer, or the neural network that this is based on, was trained off of data that was scraped off the internet. And so all of this data on the internet also has all sorts of sort of intrinsic biases in it. And you can see that there's, you know, the bias towards, you know, Toronto being the best at has to do with something in terms of, you know, economy, digital economy, the fact that Toronto is perhaps a hub of, you know, innovation, startups, you know, tech companies, world-class universities. You kind of see that this is the type of information that's out there and freely available on the internet. But you might also say, isn't Toronto, you know, the best city in the world for lots of other things? And maybe those other things just aren't represented in the data. Maybe the data that has been used to train and strengthen those connections in the neural network, you know, just wasn't available to the automated programs which train the transformer. And so, you know, as we move forward into this brave new world, you know, it makes sense to kind of pause and think about how we both consume and produce data, which is sort of the topic of the second half of my presentation. And as we look at what the big tech companies are doing, they're certainly encouraging us to interface our human, you know, bodies and actions more and more with the devices which can upload data into the cloud to be used for these training purposes. So for example, you know, I'm interfaced with my computer through my earbuds, which provides, you know, audio signals almost directly to my brain, but, you know, into my ears. I can imagine an Apple Watch, which is used to take data of your location, your heart rate, I think now your oxygen content of your blood, you know, your location via GPS, the rate at which you're walking, and provides all that data, you know, to Apple or whoever the app manufacturer is. Images, like you rightfully raise concerns about images and backgrounds of images, and home pods. Again, you know, these Apple home pods or Amazon, whatever theirs is called, was it Echo, which essentially sit in your home and listen to your voice as you give it instructions. These are all streaming data sort of constantly up in these large neural networks. I just saw a question pop up and I'm willing to take it. So just go ahead and unmute yourself. No? If not, I'll keep going. I'm going to save questions till the end. So just to continue, so, you know, these tech companies are you know, very much interested in kind of encouraging us to interface more and more with the artificial intelligence which lives in the cloud. And things like smart glasses are just the next iteration of that evolution. And you can really ask, you know, since this is progressing so rapidly, you know, how far will this technology go? How long until I can surgically implant my earbuds or HUV instead of True North, you know, Focals by North or whatever they're called, which is I think a Waterloo, Toronto-based startup. HUV, you know, heads-up displays on my contact lenses, or you know, similar things like that. And you know, it seems like the distant future. Sorry, I'm just going to skip over one. But really, you know, companies like Elon Musk's Neuralink are really trying to get data, you know, directly out of you, and not just your, you know, voice or your thumbs or your position, but really directly out of your brain. And again, it seems like science fiction, but there is a large, well-funded, very highly organized operation, which is trying very hard to normalize the idea that direct brain interfaces for the purposes of uploading and downloading data, and it's nothing that hasn't been experimented with before. We're talking about EEG signals and stuff like that, is under active development. So it's fair to ask, well, maybe this type of technology can address issues of inclusion and barriers to people that maybe don't have the ability to type or the ability to speak. But what are the consequences that come with lowering some of these barriers to inclusion? All this data shapes how we see the world, even now. And I'm not talking about visually seeing, but I'm talking about interfacing with the world. So recommendation engines, if you use YouTube and you click on the next suggested video, that has been tailored to you by your data usage. Any of the searches you do in Amazon have been tailored for you based on previous searches and previous purchases. Any ads that you see, Google, anything, any search bar, the world that you interact with virtually has really been shaped for you personally by your data. And the artificial intelligent recommender systems, which have been trained, haven't entirely been trained on your data. So they've been developing biases based on either historical data or current user data from other demographics and other communities. And so we have to be aware that the AIs that we interface with are really products of the data. They're as good or bad as the data that they've been fed for the last year, month, day, maybe longer or shorter. So I'll leave it at that and we can have a discussion. And I just put up the 2 points that the organizers emphasized. Science and technology has progressed faster than policy, certainly. And some of the big companies, the big tech companies, even rival the policymakers. I mean, they really make their own policies for how they use your data. And good luck in getting the government or any other policymakers to sort of keep up with some of the innovations coming out of these companies. And that makes us wonder, how much can we trust them ourselves, right? We trust, say, our government and our regulatory bodies. Do we trust big tech? And of course, there are risks involved, but the technology somehow doesn't stop, And so how do we best mitigate these risks to maybe improve inclusion as much as possible without sacrificing things like privacy in the end? So that's it. Thank you for paying attention, and I'm happy to take any questions.
I did have a question, actually. I have been involved with security in computers since back in 1997 when we were integrating NTFS into Windows and clouds were being created. My question is in regards to intellectual property and the coming of ideas and in discussion groups and AI piracy, people that are out there that are trying to steal information and steal ideas. What about things like intellectual property that can be released, such as like music, that can be released beforehand and get away with it while it's too late?
Intellectual property is a very interesting sort of topic. So a lot of the underlying technologies are covered by patents and commercialization agreements, which aren't necessarily honored by all parties involved, or aren't always litigated by all parties involved. Let me put it that way. So it's an interesting question about what counts as intellectual property. For example, mathematical algorithms, I found out recently, do not count as a patentable kind of IP. However, instances or implementations of algorithms into code or even pseudocode may. Is a data set count as intellectual property? Is it something that can be protected by patents? these are all interesting conversations that I'm not sure are sort of mature, understood in a mature way that's been keeping up with technology. And let me tell you,
it's that aha moment in the classroom. It's that aha moment at the discussion table. Who's listening in?
Absolutely. No, it's when I talk to intellectual property experts at the government level, they're very concerned with sort of nationalistic policies about how, we develop a lot of this technology in Canada, and how is it, released to the world? Who's using it and for what purposes? For what purposes might China be using deep neural network facial recognition technology that's developed in Toronto? Certainly things to think about. I can look at the chat and answer questions.
Actually, this is Yuta. Thanks so much, Roger.
Okay,
I have just a few questions. One of the things you talked about or alluded to right at the beginning was this notion of the data impasse. Without our data being part of it, we aren't recognized and understood by whatever smart systems we wish to make use of. But within, and that is of course one of the biggest concerns with AI ethics issues. But something that I think is fairly unique, or not, I mean, it's more unique or intensified with respect to disability, is the additional bias towards the majority and against minorities and outliers. So even if we have full proportional representation, then there will still be that, certainly in population-based decisions and also in recognition systems. AI systems are doing the same thing that any quantitative data analytics is doing. It is decreasing diversity and complexity and reducing that. And so in any situation, if you are far from the norm, far from the average, then the systems won't serve you as well. And in many cases, you might be the false positive and therefore collateral damage, or within a security situation, but also the systems won't work very well for you and the decisions will be against you. We see that quite a bit in health AI, especially now, COVID triage systems and health monitoring and many other scenarios. Do you see any advancements in AI systems that can address that? And then I have one other question to follow up with that.
Sure. So I probably believe that the best way to address the decreasing diversity of AI systems is for sort of an inclusive community or a diverse community to actually offer up data sets. And I would point towards these standard or standardized data sets. Like, I can give you a couple names, CFAR10, MNIST, or the one that I showed, ImageNet, which are used as benchmarks to typically test new AI technologies. So, it would be nice to have a sort of more inclusive community volunteer a data set, a standard data set that could be used, to train and benchmark AI systems as they're being developed. Because the alternative is
that doesn't, however, address the whatever happens. I mean, we would overrepresent then. I mean, the only way to push back against the overwhelming of the majority of the minority would be to overrepresent the minority, and which then again takes us away from this notion of being able to address diversity. The one issue with respect to disability within any data representation is that there is no common cluster of data points that identifies disability. People are highly, highly diverse. There's no common data element other than potentially self-identification as having a disability, but in many cases people don't self-identify as having a disability. And so the types of biases towards the majority, I think, will happen even if, as Microsoft has put it, we quench the data desert. with respect to outliers and minorities that have disabilities.
No, not to be pessimistic, but I think the data which is currently being trained, I mean, Amazon recognition, AWS recognition trains on billions of images and videos a day. It's very hard to counteract that, you know, with kind of hand-picked data sets. And, you know, on one hand, I'm a proponent for diversity and standard data sets used for benchmarking, but you're completely correct. On the other hand, I think you called it the data impasse. You know, the other way that our data interacts is, you know, it's voluntary because you sign a terms and agreements to use the app, but really we have no idea how that data that we as a community upload is being used to train data. And I mean, maybe one point is that we, you know, going into the future, it's going to be very hard for us to really control the amount of data that's being or the type of data that's being used by these organizations. Sorry, I don't have a great question or answer.
This is Gloria. I just want to mention we do have a couple of raised hands in our attendees. So I have another question here from David. The U.S. Justice Department just filed an antitrust lawsuit against Google. In your opinion, does this augur well for future containment of AI malethics and ignoring persons with disabilities?
I hope so. I think it's kind of the first, you know, shot fired maybe by these two adversarial, you know, interests. One, you know, the tech giants, which have their own, you know, profit-driven interests, right? And that's one thing to keep in mind is that, you know, the main business model of a lot of these drivers of technology is really profits and delivering ads to you and me. And so this is balanced by, you know, governments, you know, and other organizations that that sort of have different incentives. But I think this is a good, you know, possibly a good sign for maybe regulating and these tech giants. But I think it's also probably a very long uphill battle. Let me put it that way. There's a lot of power on the tech giant side. And I think like we're talking about here, the technology moves so fast compared to regulatory sort of, you know, bodies that, you know, it's kind of hard to stamp out a fire that's racing far ahead of you. So I'm optimistic, but we'll see.
I have a question for you.
Thank you.
My question is the government app, okay, for the COVID, okay, and the government of Canada is suggesting you download it, and even Premier Legault, our premier in Quebec, he said to download it. Knowing what you know about data and how artificial intelligence works and how the data is collected and what, would you use the app and would you download it?
So I do use the app. Yes, I did download it. Okay. As much as any mere mortal like myself can understand how the data is sort of being used, you know, I personally made the decision to trust that app. But again, a lot of that has to do with trust you have sort of in the government, in the fact that the government has done a due diligence on the data sharing and the technology within that app. So really what I'm doing is saying I trust the Canadian government to know what it's doing when it issues this app or when it recommends usage of this app. Now, as a technologist, and I don't have the skills, but somebody could, you know, look at perhaps how this app, you know, transfers data and tries to really understand whether or not, you know, patterns could be detected in this data that can violate privacy. But in this case, I think the benefits outweigh, you know, the risks just from a public health standpoint.
That's what I thought too, but I wanted to hear.
Yep, absolutely.
Another opinion. Thank you.
Thank you.
There's a hand up, by the way.
I just want to bring up, before we go to Mark's question, just want to bring up a previous question in the chat. There's a question about, I'd like to know if there is a realistic balance between user privacy and progress.
A realistic balance between user privacy and progress. Yeah, you know, I think I think we don't do a good job on privacy, and I mean, when I mean we, I mean technologists. Oh, yeah. Sorry, a lot of it comes down to, you know, when we click on approving terms and conditions, as some of you pointed out, these are very opaque. They're like legalese. They're really not written in a way that is meant for us to understand. And so what we effectively do is sort of trust, you know, the party that we're giving up our privacy to kind of treat our data with respect and to not do anything sort of malicious with it. So I think a lot of you know, a lot of this balance, you know, a lot of this is out of balance, and it'd be nice to sort of see, you know, a more transparent, you know, user terms and conditions for all of these apps, and to have sort of a, you know, a user bill of rights that's maybe more universal, that really lets us know what's being done with our data. But in absence of that, you know, unless you read every single one of these user terms and agreements, it's really hard to know what's going on with your data. And that data is definitely used to accelerate progress right now. Let me put it that way.
Thanks, Roger. Maybe we'll jump to Mark now, who has his hand raised.
Thanks. Can you hear me now?
I can hear you.
Okay. Mark in Montreal, Sandy's husband. My question is about universal uniformity in terms of, for example, with the use of English Braille, there is an International Braille Union. With respect to technology, are there anything, formats or regulations in place to govern the use of how the artificial intelligence information is, once gathered and used, is formulated in such a way so that there are agreements between, you know, what Microsoft can gather from Canada as opposed to the States? A lot of these apps that we use on the iPhone with VoiceOver are not even Canadian apps. And so I'm not usually concerned about privacy. What I'm more concerned about is uniformity of the app and how that information is extrapolated and either shared to us or shared to the users, and how user-friendly it is, say with VoiceOver or with the folks using Android and talks on their phones as visually impaired people, and how we can make that better rather than Facebook saying just two people standing with trees and snow in the background and that's it. And we know there's more there because I can show Sandy the picture and she can tell me, hey, this is what it actually is that somebody posted. So I guess I have a few concerns, uniformity being one of them.
I think the uniformity question is difficult. Different jurisdictions, like Canada versus the US, you know, treat the data of their citizens different, but oftentimes data, you know, traverses these jurisdictions. You know, Clearview AI is a good case study. So, you know, for example, there may be many laws in place that prohibit, you know, police forces from, you know, sweeping up data about the country's citizenry. So, you know, police generally don't walk around with cameras filming you on the street, and then sort of like, you know, searching the, you know, these images, and just to build sort of databases of its citizens. But Clearview AI, I believe, got around regulations by you know, by collecting data and then selling it to police forces. So there was no laws that's in Canada, and I believe in the States, that said, you know, law enforcement could not buy data from a private company. And so, you know, don't be naive when you upload your data or you interact with data through an app. You know, you really don't have much idea where that data goes afterwards. And if there's no assurances of anonymity, I can't say that word, and so on, you know, you could easily find yourself in a position where these apps sell your data to law enforcements, even spy agencies and things like that. I don't want to sound paranoid, but I think a little bit of paranoia will help us all in the long run.
Thanks, Roger and Mark. We
Thanks
have
for
a
allowing
couple.
me to share time on here. I really do appreciate it.
I appreciate it. Thank you.
We just have a couple more questions. We appreciate you staying late. Sybil,
Absolutely.
do you want to go ahead and ask your question?
Hi, sorry, I was muted. Hi, Sybil. I have a question, more of a technical question, just that something I've heard about AI that I'm not sure I fully understood. So maybe you could explain to me how it works and if this is true and how it could be used and what the risk could be. So my understanding is that you can, if you're looking at like a data plot, that there's like, you know, there's sort of, let's say a cluster here and there's like little, can you see me? There's like smaller
Yes.
clusters around the bigger cluster. And then some of there's even smaller clusters sort of towards the outside. Is trying to be able to like actually, instead of focusing on what's the biggest cluster and trying to get the data sort of within these categories, is to actually start to look for the smaller and smaller and smaller and smaller clusters further towards the outside. And not only to identify what those smaller clusters are, but how they may overlap or intersect. So is it possible that the one that's a tiny cluster on the upper left corner of a page might be related somehow to the cluster that's on the upper right? Maybe they're the opposite. They're like people who are never the same population. Maybe in some circumstances they are the same population. And so actually in a way sort of looking at data from intersectional ways too, not just populations intersectionally. So are there techniques like that that can be done that actually specifically go towards the edges, try to identify what those kind of common traits are? I think of, for example, within neurodivergence, we know now in 2020 things that weren't known in 1990 about certain patterns, even across whether you're talking about like dyslexia or autism or ADD or nonverbal LD or all sorts of ones, that there are certain common things that tend to be more true among populations of folks who are neurodivergent than others. For example, issues with executive functioning. Is that something that one could like almost use data to actually try to identify what those kind of outlying patterns are? Or for example, with autoimmune disorders, things that might trigger autoimmune disorders that are really outlying, but actually trying to find those patterns and the relationships between them.
You know, it's a great question because I believe a lot of our knowledge derives, you know, in the past, before artificial intelligence, derived from the ability to sort of take an image, you know, you segment, is kind of what you're talking about, image segmenting, you know, maybe I'm in the foreground and people in the background. You remove these three people, say, and look at each one individually, but ignore the correlations between them. And with artificial intelligence, the ability to sort of ask questions about the correlations is certainly increased. So you could ask all sorts of questions about correlations between, you know, images in the background, text, you know, that isn't part of the main theme of a document, and maybe, you know, voices in a room and things like that. But what you sacrifice when you look for these higher order correlations between, you know, objects or words or so on, is the ability to interpret a lot of times those correlations. And so you can easily build predictive models. You can think about generating or discriminating as tasks that take into account correlations between larger groups of objects. But when you go to interpret, you know, maybe as, you know, for example, maybe you're part of a community that you know, is flagged by law enforcement, for example. So not you personally, but the fact that you have been, you know, targeted or by data, maybe images or geolocation data, as being part of a community. That's a higher order correlation. So say you were targeted by law enforcement and you could ask a judge, you know, why was I targeted? And they can say, well, you know, it's really hard for us to say specifically why, because all of these higher correlations, which artificial intelligence systems are clearly, you know, adept at identifying, can't be interpreted by humans. And so the big danger of, I think, moving forward, and maybe it's a benefit, but also a danger we have to balance, is the fact that higher order correlations that emerge in artificial intelligence systems are very complex and are difficult to interpret or explain. So it's, you know, it interfaces with explainable AI.
Thanks, Roger.
But it's a great point.
Thanks. We have time for one last question. We're going to make it really quick. Richard, please go ahead.
So thank you for your presentation. It was quite interesting. I just wanted more of a comment and short question, but one of the things that it was kind of initially fearful of, and then also impressed with, was how the AI works within applications we use on a daily basis for accessibility issues as well, reasons as well. Like, for instance, PowerPoint. If you're adding photos to slides, if you're running PowerPoint with a screen reader, a large print screen reader, it'll identify the contents of the photo using AI, and a lot of times the content, the descriptions are really quite accurate, and sometimes they're not, but definitely more accurate than, say, what Facebook generates, as Mark mentioned, as far as the two people in the snow. But it is quite impressive. But I was just wondering, how do we, if we as people with disabilities want to contribute our individual examples to the data sets? Like, if I'm seeing AI, it'll tell me something like, there's a dog on the table, which was a dog on a mat, and the one time that I had. But how do I, like, I don't know if there's a way, unless you're beta testing the app, if there's a way to correct that in those kinds of situations with apps specifically for people with disabilities.
For the apps, yeah, I think you would either have to beta test, or you would have to, like, be part of the community that agrees to let your data, you know, be uploaded into the app itself. Down lower at a base level, you know, when I mentioned these standard data sets, there's certainly communities of machine learning researchers who do foundational research that, you know, could be approached, like, by an organization such as this, to include a more diverse data set. So, I mean, again, data sets that are used for benchmarking of basic, you know, functionality of new AI systems are available online in sort of standard huge databases, CFAR, 10, you know, the ones I mentioned, MNIST, ImageNet. So those things can just be voluntarily given out to researchers. But also, you kind of raised an interesting point that different apps behave differently, and some are better than others. And largely, it has to do with access to the cloud, I believe. For example, the neural networks available to your phone when you have a data link and you're using an app are much different than if you, say, had the data shut off or you were out of cell phone range. And the reason is, even though neural networks can be programmed onto your phone, they're much smaller and less impressive than the massive AI that are being built by the tech giants. And so if you notice performance differences, a lot of time it has to do with the sort of size and sophistication of the artificial intelligence system, the largest being up on the cloud, but also the amount of data that is being streamed through those AI systems in real time. And I again point to Amazon Web Services. You can go on to AWS and fool around with some of their say image recognition programs and so on. And these things, again, are trained by billions of images and videos a day. And so it's hard to compete with these massive cloud AIs on individual apps. Very good point. Thanks for your question.
You're welcome.
So thank you, attendees, for your questions, and thanks, Roger, for sharing your valuable insights. Just want to ask Yuta, our director, to say a few words before our closing comments for today.
Thank you. And thank you so much, Roger, and the amazing working groups. And thank you for our audience with respect to the very provocative questions. I think one of the things that certainly we are focusing on in WeCount is the fact that inclusive and accessible data science requires culture change. And one of the issues is that data is from the past. AI amplifies and automates the patterns of the past. And part of that pattern is in decreasing diversity and complexity, which has a disadvantage, of course, for people with disabilities, but also for society as a whole. And one of the goals here is to increase the understanding of diversity and complexity, which is where anyone with lived experience of disability resides at the moment. And so we hope that disability and the opportunity to guide any of these technical systems that are emerging to address both the opportunities and the risks that are felt by the disability community is going to result in a more humane and innovative AI. And we'd love to continue the conversation with you, Roger, and recruit you into this effort, as well as everyone that has been doing the assessments of the apps and anyone within our audience. So thank you again.
Certainly, I'd be happy to, and thanks so much for the opportunity.
Yeah, thank you, Dr. Roger Melko, and thank you everyone, participants, attendees, and facilitators for presenting and joining this webinar. It was really interesting to see what the groups have accomplished in all three parts of this workshop and hear your thoughts on the intersection of AI and assistive technologies and the impacts of AI in society for inclusion and for people with disabilities. So this webinar was recorded and it will be available on YouTube with captions for you to view in the near future. And we'll also be taking the findings from all three parts of this workshop and presenting them on our website. So stay tuned for that. You can follow and connect with us on our social media accounts as well. We're on Facebook, LinkedIn, Twitter, Instagram, and YouTube. And again, thank you to all attendees, participants, Dr. Roger Melko, facilitators, Utera, Karen, Vera, Sepide, and Dana. And special shout out to Gloria, Lorna, and David for your hard work in organizing this. We cannot have done this without all of you. So thank you so much, everyone.
Thank you.
Thank you.